Hello everyone again. So we are starting our user meeting number 8. Here on the screen we can see the content of the previous 7 episodes. They all are available on our YouTube channel. So if you've missed anything, please revisit. Today we will be discussing a few more topics. So we'll start with a description of our new tools, which we call Grok Tools, which are instruments for the developers of the extensions. We previously did have a collection of disparate tools, but now we have harmonized everything, and the new system looks a lot better than the old one. So Diana will be showing us how to use it. Then we'll go to the topic of how to integrate how to set up your development environment. Then we'll take care of that. He will be doing that with an example of Visual Studio Code, but a similar process applies to any other IDE. Then perhaps the main topic for today, we will be discussing different ways to define and store metadata for, well, pretty much anything, starting with tables and projects and ending with files, unstructured files that reside on your company's shares. We did come up with a very flexible mechanism for defining your own ways to extract and search for the metadata in that unstructured context. Alexander will be covering that one. The next one, we will take a quick look at one of our recent experiments, which is what people don't usually do in the browser. So we will be talking about digital signal processing performed right in the browser. And we are talking about big data sets and all sorts of filtering and Fourier transforms that works right in the browser in the context of the Datagrok platform. And then, if we still have time after that, I'll cover some of the news and plans we have on the front of Kim Informatics. So we have some exciting stuff there as well. Before we start with the presentations, perhaps any ideas, or is there anything you want us to cover in full, in more details? Okay, great. Then let's proceed with our first topic, which would be Grok Tools. And Diana, I just made you a host, so you can start your screen sharing. So Diana is one of our recent hires. She's only been with the company for slightly over 1 month, but she's already done some very great and impactful things. So Grok Tools is just one of them. So Diana, the stage is yours.
Thanks, Andrew. In this introduction, I'm going to present our new tools for package management called Grok Tools, Datagrok Tools, which you can install via npm. As you might know, developing packages is one of the ways to extend Datagrok platform with your custom viewers, scripts. You can see the full list of entities in our documentation. So if you need some steps to get you started and some details about package development workflow, please check out this article. Yeah, and last month we decided to redesign our old tools for package management and create a single self-documented entry point, which we called Grok. The core motivation behind this decision was to simplify package management and to provide links to our documentation also, and to create a single tool which will be easy to use, hopefully. So after installation, you can just run Grok in your terminal, and you'll see the documentation, the main page, and the list of commands available. And now let me show you how to set up the environment and start developing your packages. So the main command which to start with is config. So if you run grok config, you're going to configure the preferences regarding your default server, and also provide your developer keys. You can only you just need to do it once, and then you can safely forget about the keys, because each time for a new package, you're going to the program will look up this data, and you don't need to repeat this step for each package anymore. So now if you want to create a package, it's just one command. So you type that, and that's it. You now have a folder with a default package template. Yeah, and
Diana, apologies for the interruption. Can you please make me a co-host? I made you a host, and I see people waiting in the room.
Yeah, sure. How would I do that?
Yeah, that's a good question. You would probably right-click on my name and select more, and then make a co-host or something like that. You can also probably just admit the people who are in the waiting room, but I'm not sure how to do that. Oh, perfect. Okay, great. Thank you.
Sure. Oh, I cannot share my screen right now.
Okay, so now I've made you a co-host, so probably...
Okay.
Okay, great. Thank you.
So yeah, we've created a package, and now we can use other Grok commands to add entity templates. For example, with Grok add, you can see the list of entities. So you can add a template for your app, for queries, for connections, and this is done just to get you started, so you can start developing really quickly. So it works if you've created a package. You now run grok add app, call it my app, and the application code will appear right here. So that's done to really help you start developing in our platform. You can add more entities if you'd like. And the program will add more code. And if you want to publish a package now, you can do it with Grok Publish, or alternatively, if you go to your package JSON, you have all the scripts generated for you, so you can use your IDE to run scripts for publication. And now, if I go to Datagrok and just refresh my page, hopefully I'll see my package. And if I go to packages, yeah, now I see it, and I can explore the contents of the package right here.
So, Diana, what sort of entities can we add through that tool? So we've seen functions, queries. Was there anything else?
Yeah, surely. You can add apps, queries, connections, scripts in different languages. We support Python, R, Octavie, JavaScript. And I think that's it.
Mm-hmm. Yeah, and yeah, just to clarify, it can also be done manually. So at any point of time, if you already are familiar with the platform and you know what to do, you can go ahead and modify the sources the way you want to. So this is just a convenient entry point for adding new stuff. So the system just guides you through what's available, and then creates stubs for different things.
Yes, Diana, I actually have one question for you. Since I'm gonna talk about debugging from the Windows user point of view, may I ask you about debugging on Linux? So basically, you showed us how you build and work with the package from Visual Studio Code, and in there you had configurations available. Does the debugger work out of the box in that setup for you when you just choose the configuration and run it?
Yeah, it works. I just basically installed Datagrok Tools, and for Ubuntu, for VS Code and Ubuntu, it works perfectly.
Awesome. Yes, and thank you for the answer. The point here is that I will give a rather advanced look on how you can debug packages, and there are numerous ways you can do it. However, things already look good out of the box when you create a package using Grok Tools and have them available. Thank you, Diana.
Thank you.
Yeah, thank you, Diana. Any more questions for Diana? Okay, yeah, then let's move on to the next topic.
Okay.
Then I've just made you a host, yeah, which means you will have to pass it to someone else at the end.
Yes, thank you, Andrew. Let me share. Okay, hi everyone. So today I'm gonna show a little bit of things around debugging packages and applications in particular on Datagrok. And before I proceed to Visual Studio Code, let me just point you to one place, and this pertains to Windows operating system, which quite some of you may be using. So when you use the grok command called So what was the command, Diana? What was the command to initialize the package
grok
with your credentials? Grok? And then
grok config.
grok config, yes, exactly. So grok config actually adds this one file in the standard location for that kind of config files, where you can change your credentials. And in my case, I'm gonna use the developer's version of Datagrok, where I should provide the developer key. And that's very important to do. Otherwise, you won't be able to deploy the package. And this is the place where you can get the developer key. I won't show you this on the screen. You just need to go to your user profile and hit that link. And later, you could either provide this key while using grok config, or later you can modify this config file yourself. Just remember the location or get it from the grok tool help. And after you have done that, you could proceed with building and debugging your package for Visual Studio Code. And in my case, what I wanted to do is that I wanted to slightly customize the build steps. First of all, I created a very simple app, a Hello World app that just makes a pop-up with the text. And I made a couple of files which form the Visual Studio Code configuration. That's really convenient. In Visual Studio Code, you don't need to sort of install any configuration for it. You just need to take these config files either from somewhere, for instance, you have them pre-made for yourself, or you can maybe later take it from our grok tool that will add it to the folder if you provide an additional parameter. We are currently thinking of that option, but right now it's not something that we provide. And there I would like to point you to basically two files. This is the launch configuration and the tasks configuration. So in the launch configuration, what I basically do is I call a certain task. After that, I open my Datagrok location with apps so that I can proceed to my app. Alternatively, I could provide a direct link to my app that has to do with the form of the endpoint URI that your app provides. And then in the tasks, I specify a rather old school task where I combine rebuilding the package and publishing this package to the dev.datagrok.ai. So for me, this is rather a combination of the two steps. You could achieve the same roughly if you just add your own step that combines Webpack and grok publish. And after I have done this in my working folder, I need to do two things in Visual Studio Code before it starts to work. I need to install an additional debugger for Chrome. At least this is what I had to do on Windows. I just open this menu item, additional debuggers, and I search for Chrome, and then I install it. Okay, and then I need to go over here and find my debug dev configuration. This is the way I named it in here. And now let me just go back to my application code and see that things work. So when I press the start debugging button, an instance of Chrome browser will be opened. And if you do this very first time, this browser is not going to be your kind of default browser you use in the system. So I had to sign into that browser instance first time, but now it remembers my credentials. And Yes, so this was actually the first time breakpoint worked. I don't know why this happens yet. I'll figure this out later. Maybe some of my colleagues could explain, but I guess this has to do with the package being loaded. And then I proceed, and now I'll select the app that was uploaded to the server, and I'll get the breakpoint hit on my hello world to later see it here in the pop-up. However, I don't necessarily need to use the debugger from Visual Studio Code. I could actually do a more low-level way here. I could simply use the debugger console, developer tool in Chrome, which is available by hitting F12 button. And there I could proceed to sources, and here I would find my Hello World package. So in that Hello World package, I simply go to my source, and I put a breakpoint over here. So let's see what happens. Yes, so as far as you can see, now I actually hit my breakpoint in both places. And typically what I have here is that sometimes I just don't have Visual Studio Code at hand, and I go directly to the browser console to debug. And that's about it. You just need to know that the sources of your debug version of the package are available. And the way it works is that here in the configuration of the package, you have that line that makes debugging basically available. That pertains to the debug version of the package. And lastly, what I wanted to show you is the way to fast, not to say debug, but fast build user interfaces using Datagrok. And that's a very convenient way. You don't need to set up a package for that or set up development environment. You just need to create a JavaScript script and execute it right from the browser. So you could just go to, maybe I will just use another instance of the browser here. So you just go to scripts, create a JavaScript script, and in that script, you could do this. You could take that code, which has to do with the UI, for instance, and you could just run it. You see, yes, debugging is not available in that way of work, but it's very convenient to do changes, compose your UI, and do other things, and see the results instantly. So that's about it. Thank you for watching. I hope that this information will help you build applications faster and easier.
Yes, since you mentioned the scripting, can you please go back then?
Yes.
Actually, a great place to start with it, to playing around with the platform, is to browse the samples that are available on the bottom of the screen right now.
Yeah, this location.
Just have them, yeah, just click on the JavaScript API examples. Yes, so just open these folders, and you'll see different aspects of how the platform could be controlled. Just double click on any of the files. They are tiny code snippets that you can reuse in your own programs. So not only they demonstrate how to work with the platform, all of them are runnable. So yeah, if you execute any of them, you'll exactly see what's happening with the platform. And we do keep this collection of snippets. We add new snippets to it all the time. So that's super useful. I still use it, even though I probably wrote a significant part of the API. It's pretty convenient.
Yes, I also find this very useful whenever I build applications with Datagrok. I always have this palette of examples open. Okay, so I guess now it's time to handle the screen share to the next presenter.
Yeah, sure. If you don't have any questions regarding JavaScript debugging, I gladly will take this screen share. By the way, can you hear me well?
Yes.
Yes.
We can.
So
And you have to pass screen sharing to me.
let me guess how I do that. You share. Stop share. I just stop share and
Pass the host to me.
You'll have
Yeah.
to move your mouse over Alexander's name and then click on more and then make host. It's a strange UI.
make host. Yeah, that's it. Yes. Alexander, do you have it?
Yes, now I have
Yeah.
an ability to share my screen. Just a moment, I will start it. Okay, can you see my screen?
Yes.
Yeah, nothing special right now. I'll start with the problem. There is a problem that business has a lot of unstructured data. These data could be files, tables in databases, pictures, whatever, in many different directories, storages, and so on. And there is a problem with data discoverability. What we are building to solve this problem is the system to store metadata of such object, store properties, search in that properties, and organize data, and also provide a multifaceted browsing. This system is that we are building is completely complies with FAIR principles: findability, accessibility, interoperability, and reuse. Let me show. So here is the little demo I've made. It's earlier prototype right now, so it isn't available on the dev or on the public server. So I would show it on my local instance, but it will, I guess it will demo right things. So we have an entity-based extensible search engine inside Datagrok. Actually, it's based on entities and properties. And how you know, everything in Datagrok is an entity. For example, the table column, data query, data connection, file, directory, etc. Basically, everything is an entity. And now, thanks to this solution, every entity can contain extensible amount of properties. So each file basically can contain properties. That's a not fixed list of properties, so you can use everything as property name and put everything inside. For example, we have a file indexer, and this file indexer can index file share or S3 catalog or Google Cloud catalog or basically everything. So here is the small list of file shares we support. But back to files. I have the file share demo files. As you can see, there are many properties there, and I can filter files by properties. So what happened now is I choose image JPEG, and here are all JPEG files that are in this file share also in subdirectories. So I can find any file with property I like. That could be anything, basically: a file size, image height or width, or maybe any EXIF attribute of an image, or maybe cells count that picture that are in the picture, and all of these properties can be used for filtering. We have a special filter language also with the category filtering, so I can print something like this and get the same result. Now, some of our customers use this technology to make a custom filtering on some Datagrok objects and Datagrok entities, and it would also be used particularly almost for everything. More, this filtering system also allows you to analyze files in place. So take a look. If I choose CSV file, I can load it as a table. Oh, I can't. Some strange things. Yeah, here is basically the demo of that file, and I can work with it like with any table. The thing I want also to mention is our file indexer. I said a couple of things about that, but let's take a closer look. Basically, each of the file share is the file connection, and each file connection can be marked to index files. So now this connection has indexer job, and it can be set up to be run on daily basis, but it's now run manually because it's my local system. And what is the file indexer? File indexer can remember file attributes in the file share to allow them to rapidly search for them. And we have file indexing scripts conception. So these properties were given to Datagrok by Apache Tika. We have the package named Tika, and here is the Tika metadata extractor. It's basically the Python script. It is very similar on, basically it's the same Python script as other Python scripts, but it marked like metadata extractor. It accepts a file and returns a metadata. Executes Apache Tika, and Apache Tika provides all of these properties that Datagrok can work with. And every script can be a file extractor. Let me demonstrate it once again.
Alexander, what exactly is Apache Tika? Can you maybe?
Sure. Apache Tika is software to get the properties for files. So it accepts file data and returns a huge list of properties that describe that file. So if I step on tweet CSV, here are the properties for this tweet CSV. It was parsed by Apache Tika. It content encoding UTF-8, CSV delimiter, and content type.
So can we find all CSV files with the CSV delimiter comma?
Yeah, sure.
Oh.
Here they are. There are 52 files with CSV delimiter comma, and here they are.
Does it work with compressed CSVs and other compressed files? If PGC per file cannot extract properties easily?
Sorry, can you please repeat? There's a lot of noise and I can't recognize the question.
Can it work with a zip file?
With zip? Yeah, we can work with zip file. So let's basically take a look. Here is the zip. And
No, I mean if CSV is really zipped, if it's just internally, if it's CSV but gzip on top, can it extract properties of CSV from a gzip? Yes, that's the question. Can it look one way down into there?
Yeah, so if there is a CSV inside the zip, it will find it. But it's not yet exposed to this UI. Datagrok just internally knows that there is a table, basically, not a CSV itself, inside the zip file, but it just can't show it right now due to some UI problems.
Can the filters be combined?
Yeah, sure. So I can combine this filter and this, and it will return empty set, of course, and like this, and find something by name. By the way, we also support like this, and our regular expressions are supported there too.
Oh, nice.
And one more thing about file indexer. Yeah, I started to explain how metadata extractor works. And this script is also works as a panel. So if we take a look at the file, we see properties here. These properties were indexed by Tika, and they are stored in Datagrok database. And also here is the panel Tika that works in real time and extract real-time properties. Basically, it's the same script. The same script is used to make a panel and to provide the properties.
And this is all done by that tiny script that you just showed.
Yeah,
right?
yeah. This is all done by this script. It can actually be even smaller. Here's the boilerplate to run the Java code. Yeah, by the way.
Can we write our own script that
yeah,
would
sure.
extract some specific information?
Sure. You just need to support this annotation. You need to take input a file. There actually would be a file name. And you need to provide the output a map with metadata. There is also a condition, so you can filter files to process or to not process. And you also must set a metadata extractor tag. And basically that's all. Your custom script would work as file extractor and provide these properties data, and Datagrok can work with those properties. Also, we have a few examples of this metadata. Let me show you. For examples, here is the cell image segmentation script. Let's hope and hope it's working. And also EXIF extractor. Let's try to execute them. Sadly, it worked just an hour ago. Okay, here is the EXIF extraction script that extracts EXIF attributes. It can also work as metadata extractor and provide data for properties. And here is the cell imaging segmentation that normally should return a segmented image and count the cell counts, but I'm afraid something went wrong and it won't do this. But let's take a look at the script. This is a Python script too, written in Python and using our compute virtual machine. It has a condition that here is file should contain cells in file path, so it is a cell image, and it will return graphics with segmented image, but it doesn't.
Yeah, I think someone probably broke our development server. You can show it on public. I just tested it and it works.
Yeah. Okay, let's try on public. plugin to public. Forgotten. Okay, let's try to take a look on this. Yeah, it works. So it has 47 cells, and here is the image classification. And this output also can be used as a properties. So you can set up a file indexer. It will index share or shares, whatever you actually want, and provide information of about these files to Datagrok properties. And then Datagrok can easily search, filter, or use that properties for, I don't know, maybe like a criteria for some other scripts execution. So you can count the cells, and then based on the cells count, make a decision to execute or not next script.
So the script, it returns both the image and the metadata. How does it know that the cells count needs to be stored but not the image?
Actually, this script now returns two output parameters. We now don't support int output parameters as file indexer, but it is very easy to add, and we'll definitely do it. So if the script marked as metadata extractor, we just get everything we actually can work with. So we would get int parameter and math parameters, and ignore graphics as they are useless for properties.
Yeah, that's really nice. Can we do something more than just extract the metadata? Perhaps do some pre-processing or run pipelines and just derive some high-level features in the end of the pipeline, and then use these as.
Yeah, sure. As far as I used to work in Johnson, in near past, there was a project of extracting the biosensor data. So we definitely can build a pipeline to get a biosensor data, extract features, and then store the features as a properties and work with them later. So we can always know where the particular property came from, and we can gather them and work with them like not like, but as they are now stored in structured database.
Oh, that's great. It would be awesome to have the capability to execute some sort of pipeline as soon as the files are placed in a file share. So yeah, just imagine the scenario. You get your data from somewhere, a biosensor or a picture, something, and then you would just drag and drop it into this folder, and that would trigger something.
Yeah, that is actually possible if this file connector supports webhooks, or maybe polling in periodic. We can poll it periodically for some new files. Yeah, this is completely possible, and this can be done. And we can execute file indexing just on new files, just not re-indexing all the files that are in the folder, but just a new one. Yeah, everything is possible, and this is actually a great step forward. And as far as I know, this property and metadata system is already used by some of our customers.
Yeah, this is fantastic. Yeah, I really think we should go into that direction for pipelines and triggers. Yeah, that's
That's
certainly been an area where our partners are interested in.
yeah, I guess time for questions. If you have any questions, please ask them.
I actually have questions. Can we add more filter types? So now everything is a checkbox.
Yeah, sure. That's because the Apache Tika that I started with supports only text filters. So I just started with text filters. Of course, there will be track bars for integer or for float and histograms. That is all in our roadmap.
How about Sketcher for substructure search?
Yeah, that's a great idea. We can also easily support it. We have actually semantic type metadata information. And if we recognize that this property contains smiles or some other notation, we can easily search by substructure.
No, but I mean the search within the CSV files that would be under a certain file share, right? This information will not be available on a metadata level. It will be within the CSV file.
Okay. Yeah, why not? So we have all the information about where this is located, and we can I guess we'll need some kind of indexing of this CSV file, but it can be easily done. So.
But it won't work on metadata, right? We'll have to extend the system in order to allow that sort of search. Because in order to search, right, we would need to read the file completely, presumably. Yeah. We can probably detect metadata on a column level, though. So we would know that there is a column that contains chemical structures, and then we would be able.
Yes, we actually already can do that. So file indexer can detect if it's a CSV file and contains table. And there is a place in database the table metadata can be connected with the file metadata. And we also would know if there is a smiles column inside the CSV.
So I guess we would need to build a way to search within the content using some other script or generally a function that would be provided externally.
Yeah, you're right. We'll need to invent something to access that file data, but since we have the path and all the metadata, it can be done. It's doable.
So Alexander, Ed Yeager here. You may have covered this earlier and I missed it. What happens if you're connecting into a large file share? Is the indexing done in a parallel thread here? Can I walk away? You know, those kinds of questions. Because
sure. Index is done on our system. So here is the single job I have is demo files indexer. If I run it, I can easily go away and it will run on the server on the backend. Here is the blue dot that indicates that this job is running right now. So it actually will run a couple of minutes on this folder because Apache Tika is rather slow and we can watch.
Okay. Yeah.
So it's running. Actually, I can even close the browser and it will continue running on the server side.
And then if you go through and try and search, are you able to search on things that are where the indexing is not complete?
Yeah, I actually there is no fields while indexing is not completed, and I can search only in current folder, but not within the subfolders. So of course, I don't have access to all of these properties because they are not available while new indexing. They were deleted before new indexing with Tika. I can search only by name in the current folder. No. So, okay. Here is the little problem. That's that connections market, that there is an index files flag, and I can't search while index is creating. Yeah, we have to wait while this indexing is done. It will take, I guess, a couple of minutes, maybe 10 minutes. And until then, we are not able to use these properties for searching.
Okay.
Again, this is a prototype, so we have a lot of things to improve, and one of these is availability. So if we execute a new indexing process, it definitely should not break everything on the start, but if it succeeded, it will just add the new information, but not reset all of things.
Yeah, this is fantastic. I also think we should really keep everything completely extendable, so that, for instance, that Sketcher control for the search would be provided by a plugin, and then other packages would be able to influence both the indexing capabilities and the UI for searching. So that's probably something we need to make at the very beginning.
That's a good idea, and it's really easily doable because we have a concept of editors. We can register a editor for some certain type, maybe for substructures. And in the categories tree, there will be custom editors that can be brought from packages. Oh, here is indexing completed, and we can, I think we need to reload this view. So here are the properties. They are back again. I've just reindexed this folder.
How is the metadata stored? Can we search it in some automated way without going through the UI? Or what if I have some external application and I want to know what my, I don't know, CSV files or images with a cell count greater than 60 are? Just
Do you mean
through the API?
direct access to database or REST API?
Mm-hmm.
Okay, here are basically both ways. If I set a filter on image JPEG and take a query, here is actually endpoint to search files. So it's file and then a text filter. So all searches are done through the text filter, and you can pass the, here is a URL encoded string to filter using properties. This is one way to do it, and the second way, I guess, if someone needed, you can access database directly. There are rather simple table structures, so you can make direct SQL queries.
Yeah, that would probably make sense for organizations that deploy the platform on premises, so that they have the flexibility to search for everything, right, without going.
Yeah, sure. Sure, why not? And also you can use JavaScript API. So if you own server, so if you go to JavaScript API, wrong server again. Yeah, I need dev. Yeah. These properties are supported in JavaScript API. So as you can see on this example, here is we are setting properties with name prop and value mark and mark2 on the layouts, and then we filter the layout based this filter based on second property value. So you can also use these properties as entities filtering in JavaScript development.
So this is the same mechanism, right, that you are showing with the
this is
layouts?
the same mechanism. So you can access the files using the same syntax as you see here in search, and you can use also categories, properties, and everything.
Mm-hmm. So are the properties strongly typed, or are they structured?
Not right now. Basically, there is only support for string types right now, and I'm working on other types. But no, we should support any type, including a binary property, I guess, and there is no restrictions to keep whatever you want.
Mm-hmm. Well, yeah, of course, the primary interest would be numerical properties, so that you can.
Yeah, sure. Numerical properties are next in my roadmap. So, okay, that is all from my side. If you have another questions, please ask them, Andrew.
Okay, great. Yeah, thanks a lot, Alexander. It's obviously still work in progress, but I think it shows just great possibilities in front of us.
Well,
so yeah, let's create
yeah,
something.
thank you. There is indeed really a lot of work to do, but yeah, we're on our way.
Right. Yeah, I think the potential is huge here. So that's a universal platform where you can both introduce the way you extract metadata, but also the way you analyze it and the way you search for it, right? And you don't even need to leave the browser because you can work with that data right there. Yeah, let's definitely keep evolving that. So maybe in some future presentation, we'll give a deeper overview. Okay, great. Let's move on to our next topic then. So the presenter will be Ivan Stankov. So Ivan is our one of our most recent hires. So he's only been with company for actually, believe it or not, less than 2 weeks, and he's been mostly concentrating on one of our exploratory areas. So we are contemplating the use of WebAssembly for different purposes. Well, mostly, of course, related to high performance computing. And we already got some very promising results, and Ivan will now tell us about all of that. So, Ivan, the microphone is yours. Alexander, please make him the host if you have not done so already.
I already made you the host, so best to
Andrew, actually, you're the host now. So you can pass the mic and screen to me.
So now you probably can see my screen?
Yeah, we can see and hear you well.
As you mentioned, I've only spent a week or about trying to learn the platform and implement something new. My first task was dedicated to highly efficient C code that we would be able to run on the Datagrok platform. We have to do it and we have to experiment with it because currently most of the tasks are run on server side of Datagrok platform, which results in time being not wasted but spent on sending data to server and back just to run sometimes not so complicated tasks that could be implemented on user devices locally. And so there are not that many web tools that would allow that. and we experimented with what's called WebAssembly, which is a technology designed to allow C, C++, and sometimes other languages to be compiled in so-called binary structures that allow that code to be ran on in web browsers. So it works sometimes in the form of sandbox. So you just have the ability to run your C, C++ code in JavaScript, but with some limitations, like you can't just allow WebAssembly modules to grow in memory, just like that. So, and yeah, it has many security logs, which are very important, but we don't need them at the moment. We are just trying to run some computations locally and save time, save memory, and save speed by implementing this technology. So what I've been trying to do is implementing some useful tools that will allow users to pre-process their data that would then help them use it with more complicated algorithms that sometimes would run on server side, sometimes maybe on local computers also. What I've been developing now is a set of filters and normalization techniques that are very useful for time series analysis, for generally any kind of sensor-based data, because it's often filled with noise, or it has to be normalized to other dimension, or maybe just somehow reprocessed and the package is not ready yet. I'm going to implement something new as well. So the project looks just like a regular Datagrok package. Let me just show it to you. So here is a common look of the package that I then sent to the Datagrok platform. However, under the SRC folder, I have some new files. Exactly this alex.js and alex.wasm. And those are just my C code that was compiled using a tool named mscripten in a binary format that I mentioned before, and what's called glue code, glue JavaScript code, that allows that WASM binaries to be seen and compiled by regular JavaScript in Datagrok generally. So WASM is basically just my C code, which looks something like this. Let me open it and show it to you. It's fairly simple yet, but we are working on more complicated things. So we are going to use more complicated libraries and generally developing more complicated tools. And so here you can see my functions that take data from JavaScript and then sending some new data to JavaScript back. C is just generally a very fast language. It allows us to store, save, load, and compute really fast. Here I have developed all the tools that are then compiled to JavaScript, WASM, and so on. And yeah, here is my most complicated thing. It's called Fourier filter. And I can show it in Datagrok platform right now. I hope it works. It worked. So all those functions that I designed in C are now seen here in Datagrok on the right. We have few simple filters, I guess, a few normalization techniques, and then Fourier filter, which is a little bit more complicated. So if I want to run my WASM code, I just run Datagrok function just like regularly. For instance, let's just use it on Fourier filter. I'll take a noisy sign, which is not really a sign. It doesn't look like sign anymore. I'll try to cut out 70% of lowest frequencies, and I won't cut any high frequencies at all. So as you can see, I've tried to compile it. It took nothing. And we now can see results. Yep. So compared to noisy sign, it looks a lot better, a lot less noisy, but it doesn't look like sign, obviously. Original signal was somewhere here, but I guess that noise signal was too high and just messed the original so that I can't restore it. But it's just a pure example of how we can use WASM to run tasks locally. So if I would want to try and use some predictive modeling technique on this noisy sign or whatever noisy signal I have, I would locally run my filter or normalization technique, and then either send it to platform or use any other available locally available algorithm that I would run, that I would want to run. It saves us a lot of time and effort, and we don't mess with sending data and converting. I think it's, well, it's a very useful technique, and I'm confident that Datagrok will develop in this area even further. I don't have that much of a demo. It's fairly simple, so my speech is almost done now. But maybe you have questions to me, and I also have a question to audience. The DSP toolkit that I've built now is fairly simple, and I want to develop it even further. But I would want to know what are the tools that you would want to see in this toolkit? What would you want to run locally before you have to implement it, before you use it on the more complicated algorithms?
So it's probably not the exact right audience for the DSP questions. We do have a collaboration with the university, so when we analyze biosensor data, so probably that would be the right audience to ask that question. But anyway,
yeah. Hey, Andrew, this is Nirali. Yeah, I just wanted to ask generally, like, where, as you said, you know, the right user base, what would be the use this, if you can give a few examples where we can use this, like, you know.
There are quite a few examples. I can answer it. So whatever sensor you have, you may want to somehow preprocess the data that's coming from it to then run on whatever algorithm you want. So in time series, you would need to do that. Some of the transformations that I have already developed here are fairly simple, but simple logarithmization is quite important in time series analysis.
Okay.
Yeah, well, almost anywhere, I guess. It's it doesn't depend upon data, but you can run it anywhere.
Okay.
Whatever numeric value you have.
Yep. So maybe like lab environments where we use sensors and
Actually, Nirali, I'll give you a good example. So during my work at Johnson, so since you are from there, one of the projects that I was intimately involved in was Mantis or Jake, where we would analyze biosensor data in the context of clinical trials. So essentially, kids would come to our clinical sites and we would put an array of biosensors on them, expose them to different stimuli, and then later on we would mine the data and try to answer a gazillion of different questions. And that was all done in order to enable clinical trials in the autism spectrum domain. So these sort of algorithms that Ivan was showing, they are central to that sort of analysis, because in order to make sense of the raw biosensor data, you first have to pass it through a series of transformations. Because initially it looks like what we currently see on the screen, where each point corresponds to some very specific point in time, and we do need to clean it, apply multiple filters, extract some high-level features. For instance, for ECG, that would be a number of heartbeats per minute, and for EEG, there would be hundreds of different other features, and then process it even further. Actually, this step that Ivan is showing today, it is connected somewhat to Alexander's presentation on metadata. So imagine if we would extract these features automatically from the biosensor signals, and then we would store metadata using that indexing and search engine. So then everything would come together within one platform.
Got it. No, that makes complete sense. So you can like train the models and can predict different things. Perfect. Yep. Thank you so much, Andrew, for the example.
Yeah, it's my pleasure. And yeah, just overall from the technical perspective, it's pretty amazing what is being done here. I'm still amazed by the technology. Browsers did come a long way from how they were 15 years ago. They are like mini operating systems, and what is done here is really we are executing some high performance scientific code written in C++ at the native speed or near native speed, as Anatoly would say, inside the browser in a safe context that just unlocks yet tons of different possibilities. I'm already thinking about how we can use and run the same algorithms on a server side and how we would stitch everything together.
Sure. No, it completely makes sense. Thanks a lot. Thanks for sharing, Ivan. Thanks a lot.
Andre, if you want, maybe next time I can show a brief live demo of a viewer based on already on WebAssembly technology, and maybe talk a little bit about how it's used for. It's a viewer for bioinformatics for comparative genomic analysis. So maybe you take it as an info.
Awesome. Thanks, Anatoly. That would be fantastic. And yeah, our next meeting is in 4 weeks. Perhaps we'll also integrate your viewer from NCBI into our platform, right?
Option 2. It's just a different viewer for multiple analysis. We didn't talk about it yet, but it's our first try to use WebAssembly and to feed complicated scientific models for multiple alignments inside the browser, which otherwise would be impossible if we try to do it in JavaScript. But now it's totally feasible to shift computation into the browser and actually get better user experience and hopefully better scientific results.
Yeah, exactly. It's a huge win for everyone. Yeah, I'll take you up on your offer. It would be great to have you presenting next time.
So I'm going to stop the share now, I guess.
Okay, yeah. Thanks, Ivan, for the great presentation. It's really interesting. Yeah, that's definitely an area that we will enhance and work on in the very near future.
Maybe I pass the host to someone else now.
Right, well, we are actually at the end of our time. I guess next time, in addition to Anatoly's presentation, I'll also present some of the work we've been doing in cheminformatics that's also related to WebAssembly, but that's for the next time. Any other questions, suggestions, remarks? No? All right, then let's give everyone 4 minutes back. It was really good to have everyone here, and I hope to see you next time in 4 weeks. Thank you.
Thank you all.
Thanks a lot, everyone.
Thank you.
Thank you.